I want to go back to this diagram here, which shows the stimulus response pathway in the peripheral nervous system and central nervous system. So you remember we've talked about this before. We've got a sensor or receptor that detects some stimulus, and we are going to carry that information via the sensory or afferent division of the peripheral nervous system to the central nervous system. This could either be the brain or the spinal cord, and there may be interneurons that talk to each other, synapse, to relay the information. We'll come back to the central nervous system more specifically later. Then we've got the motor or efferent division. This is also part of the peripheral nervous system. So we're exiting the brain or spinal cord via spinal or cranial nerves. And the motor division is then divided functionally, and there's anatomical differences, into the somatic nervous system, which is voluntary, and the autonomic nervous system, which is involuntary or visceral. So that's going to connect to those visceral organs. So first, I want to remind you of this motor division, and then tell you what we're going to focus on this week. You'll see these effectors down here. We've got skeletal muscle here for the somatic nervous system. We've got smooth muscle and cardiac muscle for the autonomic nervous system. Those are all part of the muscular system, although typically when we talk about the muscular system, we're focused on skeletal muscles, which we will be focused on this week. So let's break down this component over here a little bit more. So the motor divisions of the nervous system. So if we go back and draw a beautiful diagram of our central nervous system, as you can tell, this is CNS is our brain and spinal cord. We're going to have motor output, which are neurons, cell bodies within the central nervous system. I'm going to draw them in the spinal cord. We'll get back to peripheral versus central nervous system some more in the future. We've got neurons that project out to the periphery. I'm going to draw two different neurons here. Bundles of these axons are called nerves. I don't like this red. Let's change this. In the PNS, peripheral nervous system. So I just want to remind you, I'm drawing a single axon, but in reality, these would be bundles, a whole bunch of axons. So then we've got a couple different places these can go. So one place here, this is obviously skeletal muscle. Let's draw a few nuclei in there just so you can see them. Skeletal muscle has kind of strange anatomy, so we'll get to that. This is the somatic motor division. Shown here. So the other one is going to be some other effectors. This might be, let's just put it here, let's put cardiac muscle as one example. Where is cardiac muscle? Well, I haven't told you yet, but maybe you already know. It's in the heart. So this down here would be the autonomic nervous system. Here, this is our somatic motor. I'm going to specify that there. Again, I told you before, autonomic nervous system, typically when we say this, we are referring to the motor division. We know this is all motor because we've got a multipolar neuron that's beginning, its cell body is in the central nervous system, and its axon projects out to the periphery. I also labeled the slide motor divisions. So this week, we're going to be going over muscle tissue, both cardiac, skeletal, and smooth muscle, both meaning all three. A little bit about the similarities between all three of them. Then we'll focus on skeletal muscle, the organ of skeletal muscle, like this guy here. Then going down to the different levels, down to the cell and molecule level. With the molecule level, there'll be myofilaments that make up a sarcomere that we'll talk about, and then those are going to move to cause contraction. And then we'll go back to kind of this big picture here. So how does a neuron cause a muscle to contract? So it's called excitation contraction coupling that occurs at the neuromuscular junction where neurons talk to muscles. Then we'll do a couple other topics after that related to muscles functioning as a whole organ. All right, that's this week.